It's been raining today, so fall is coming. So I think that there is the internet problem in Zoom side. I think it's not the problem of Wi-Fi in Seoul National University, or I think there is no network problem. It's just caused by the slow speed of supplied by Zoom service. So I will slowly move the screen, and also I will take some time between each transition of the slide or any explanation. Okay, we will continue the study of the variability that is related with the queuing model. In previous lecture, we have defined the meaning of variability as the quality of non-uniformity. And this non-uniformity is related with some randomness. So that is the reason why we have to understand the basic theory of probabilistic approach. And also we have studied the performance index of the Bayesian model. Bayesian model means the balanced line. And at there, we have seen the worst case and practical worst case, and also including the best case. However, there is no or little variability in the case of best scenario. So the variability have impact on the worst case and practical worst case. But in case of worst, the performance index can be predicted perfectly by using the given formula. However, the practical worst case cannot be predicted perfectly or calculated with any given the formula. It means the calculation. So the most cases that we will handle is related with the concept of practical worst case. And nextly, we have studied about the controllable and uncontrollable variability. And most variability that will be handled in this class is the uncontrollable variability. But the setup that is belonging to the area of controllable, but this setup variability have impact on our model that will be treated later. And the examples of uncontrollable variability include some customer order that is induced by the external side, also the breakdown or any machine failure or the power outage. Those kinds are also uncontrollable factors. Also very minor, the machine errors also is included in uncontrollable variability. Nextly, we have studied the intuition, and very easy intuition is related with the first moment. That is mainly related with the average concept. For example, if we want to increase the throughput of any production system, we can easily determine the way how to increase the throughput. That is the upgrade the performance of the machine or process. It is easily predicted or easily intuited because this throughput and cycle time is related with the linear relation. This kind of relation, the intuition is first moment. However, in case of second moment is mostly related with the standard deviation or variance. And we have mentioned about the two questions. The first question is, which are more variable? It means the time to an individual part or time to process an individual part compared with a time to process a batch of parts. We cannot easily predict or calculate the variation or variability with respect to these two cases. In these cases, we have to calculate the variability in terms of the measurable index. And that will be treated at this lecture. Also, second question is, which are more disruptive or which are worst case between short and frequent failure and long and infrequent failure? Today, we will calculate the variability of these two cases, and we will see what is worst case and what is better case. Before the calculation of these two cases, I want to check how do you think about these questions. And lesson number 1 and 2. Please raise your hand who think the first case is better. Raise your hands. Or type number 1 in the chatting window if you think that this case is the better case. Please type 1. Or if you think this is a better case, long and infrequent failure, please type number 2 in chatting window. Everyone follows the first answer. 동원이는 답하지 마. Okay, now we will treat this problem later of this lecture. Okay. Before answer this question, we have to study some basic theories about the variability. The first random variable in this variability is we have to define the effective process time. Effective process time. This effective process time is the total time that is seen by a job at a system or any production line, anything. This is the definition of the effective process time. So this time include the very surely including the working time, but also this time include the waiting, and also this include the repairing. So we will use the T0 as the working time. But this effective time is the summation of all the time that can be monitored by a job that is being processed in a system. And nextly, we need to define what is variability. Before this, also we have two variables. First one is sigma and square sigma. This is the standard deviation, and this is the variation. But this standard deviation and variation can be thought as a good index for the variability. However, this is the absolute value. So it's not create for the for example, if sigma is 10 micrometer with diameter is 2 inch. The standard deviation may be thought as a very small value compared with this 2 inches. But if the same deviation, 10 micrometer, with compared with if the diameter is 5 micrometer, these two cases have same standard deviation. However, in upper case, it is very small variation. But this case, the 10 micrometer compared with the 5 micrometer diameter, this is very big deviation. So it's not appropriate only use the standard deviation or variation as a variability. So reasonable relative measure of variability have to be defined. So now we will define the variability. Let's write it. CV equal is defined as here. This is the measure of from the second moment, and this is the measures from first moment. And we will shortly call variability as CV, and CV means that coefficient of variability. This is the definition of CV, coefficient of variability, that we will continuously use in this class. And also, scared CV can be defined as a square value. So sometimes we will use CV, and sometimes we will use squared CV. And also normally this is the relative value, and the region of the value is known like this. If the CV is less than 0.75, it is called, it's belonging to the region of low variability. And if CV is greater than this and smaller than 1.33, this is called the medium variability. And lastly, if CV is greater than 1.33, then it is belonging to region of high variability. It's not the absolute value, but it is well known the region of coefficient of variability in the most industry cases. And among these, the exponential distribution is belonging to this medium variability, because the variability of exponential distribution is 1. And later, this value makes the calculation very easy to handle. Actually, also this was already related when we have deduced the exponential and the Poisson distribution in previous lecture. Okay, this is the simple definition of the variability, and more thing is that the low variability is mostly related the status of if there is no machine failure. And in case of the medium variability, in most cases is simple adjustment. And high variability is related with the status of very long breakdown. But those are just a relative concept. It's not the absolute value, just the roughly categorized. So it will be very different in the shipbuilding cases because the shipbuilding data is mostly belonging to the region of high variability. And previously, when I have analyzed the production planning data of the shipyard, we have seen the very big value of CV, even the close to 7 or 8, 9. So anyway, let's get now let's see what is the major causes of variability. First one is the natural one. And this natural variability is mostly induced by the fluctuation in process time. It means that this natural variability is not related with any breakdown or waiting or the operator's availability. Those kinds, the impact is not belonging to natural variability. Natural variability is only concerned about the process time only. So in case of the manual work means that the work is conducted by the human. In this case, this natural variability can be relatively big value. But compared to this, in case of the automatic machines, the natural variability of automatic machine may be very small. But even though the automatic machine cases, there exists a natural variability, even though it can be very, very, very small value, but it exists in the machine, in the automatic facilities. Anyway, this natural variability is very inherent one that exists anywhere. That is conducting any processing or manufacturing. Next cause is the random outages, mostly related with breakdown or malfunction. These kinds of things is not scheduled in advance. No one schedule the time to make a machine to be broken. It means that breakdown or malfunction or power outage, these kinds are not pre-scheduled. It means that this kinds of accident is randomly occurred. So these random outages have very big impact on the variability. And next one is the setup. Setup means that some kinds of installation or any kinds of preparation for the next job. Mostly the setup activity is occurred when the kinds of product is changed. For example, in case of shipbuilding, when a certain shape of the hull block have to be assembled. At the case, the supporting jig have to be installed in advance before the assembly work. So the kinds of things, the kinds of activities belonging to setup. And also the variability of operator. Operator means that worker. And also the recycler. These kinds of activity have impact on the variability. And we will handle mainly these two, random outage, it means the breakdown, and the setup activity. Now we will define this one. Natural variability. It is inherent natural process time. And as I have mentioned, this is not explicitly shown up. And also, it is more natural variability in manual work compared with the automatic. But even in highly mechanized the robot, there exists So we will define this variability as C0, and it's defined as T0 over sigma 0. And this value is the only rated with machine or operator. So this is not related with any kinds of the operation. Operation means that waiting or some breakdown. It is only related with machine or the worker itself. And based on this natural variability, the failure or setup increase the overall variability. So now, from now on, let's find a way to find and quantify this effect, failure and the setup. First one is setup. First one is the breakdown. We call it the preemptive outage. And for the Korean students, it is called as like this. And breakdown similar meaning, but failure or power outage. This kinds of activity, the event or accident is belonging to preemptive outage. An important thing that is noted is that this is occurred in the middle of job. So if let's think the status of this preemptive outage during the working, and any job is staying inside of the machine. At some time the breakdown is occurred. Then what we have to do? We have to repair the machine. Then during the repair of the machine, what is the state of the job? Job we have to wait until the completion of repair. It means that this job have to wait the completion of breakdown, and if the repair is completed, then this waiting job have to be continued, and this continuing means the preemption. Can you understand? Preemption means that some reservation in advance. So if the machine is broken and the job have to wait. And later, the breakdown is being repaired. Then this waiting job have to be started again. And this is being said as a preemption state. Okay. Now let's calculate. Now let's have an example. We will use example of the same name that is written in textbook factory physics. There are two machines, here X19 and tortoise 2000, and each have a natural work process time T0 15 minutes and natural standard deviation is this is same with respect to each machine. But these two machines have different breakdown. Means that in case of the X19, the mean time between failure is hour and repair time is 4133 hour. That is M means the minutes, but tortoise Ichan, the 2000, have the mean time between failure as 1.9 hour and repair time is 0.633 hour. That is 114 minutes, and this is 38 minutes. Now, this is the example that we have mentioned in previous. This is the long and infrequent breakdown, and 2000 motion is short and frequent breakdown. Let's make some simple assumption. Means that let's make the CV, means the coefficient of variation of repair time, as the 1.0 for both machine, in order to make a calculation simple. We will use this value later. Everybody know the mean time to failure and time to repair? if this is the progress of the motion time, that this region, if we assume this is the t0, let's see this. Mean time between failure, MF, means that the I have to draw again. Let's see this. If the natural process time is T0 and the repair time is MR, then mean time between failure is the, sorry, this is not good one. Then this period, this is the mean time between failure, and mostly noted as like this: mean time MTBF, mean time between failure. So this is the duration, that is the period of the working duration between the occurrence of the failure. Now we please see this example closely. Here 19 and tortoise 2000. With this example, we have to firstly calculate what we have to calculate firstly. We have to calculate CV, is it right? Calculate, and this is can be written like this, right? Then we have to calculate these two terms, okay? And firstly, we will calculate this T effective process time by using the natural process time. And we have to do something here. Also, we have to do something here. Then firstly, we will conduct some calculation for this transition from T0 to TE. In order to calculate TE by use of the T0, we have to we have to adopt a new parameter A. A means that availability. This is the actual fraction of time that is the machine is being operated. Here, both machines have the same natural process time, that is 15 minutes. However, these machines will have a breakdown periodically according to this value. So, at effective process time may be bigger than this value. Is it right? So, availability means that the actual process time, and it is defined as like this. This is the availability. And if you and by use this availability, TE is calculated as T0 over A. So if we calculate this availability of both machines by use this value, in this case, this is becoming 20 minutes. Please calculate later after this class. It's just a simple calculation. And both machines have same process, the effective process time, 20 minutes. It means that in average perspective, these two machines are operating the product, one product per 20 minutes. So from this, we can also calculate the effective bottling ratio. And this is defined as the reciprocal number of TE. And for the future use, extension of this bottling ratio, we will adopt the variable M. And M means the number of machines. But for the time being, we will use only one machine, single machine. So in this case, it is M equal to 1. And in this case, if we use this value and convert to from minutes to hour, this is the 3 products per hour. This is the bottling ratio, and all this is same to X19 and 2000. And this is the concept of first moment. It means that if we consider the only average value, average is the effective process time, these two machines are same, exactly same, have exactly same performance index. It means the two machines have the same production capacity in terms of effective process time. That is the belonging to first moment consideration. However, these two machines may be different if the variability effect is included. And we will study about this. Before the calculation of the exact value of CV, we will go through we will use our some intuition. It means that in the let's think the state of the cases when these two machines are broken. In case of X19, WIP is required equivalent to 4.133 hour. Do you remember this value? 4.133 is this value, repair time. So if the X19 is in state of broken, and in order to continue the production, this workstation have to keep the jobs. The number is equivalent to the 4.133 hours. And in case of 2000, WIP equivalent to 0.633 hour. Without the consideration of the chain reaction between the following and preceding operation. It is just the very simple imagination. So from these numbers, the Tortoise 2000 is more efficient because the same production output, it means the same throughput can be obtained with a fewer number of WIP compared with the Hair X19, because it is very natural that the WIP that is required to compensate this duration will be smaller than this value. It is very easy the imagination because and it's very simple. But now we have to calculate the variability in order to how much is the better any one of the machines and how much is the worse. So now from now on we have to adopt some very complex the formula in order to the CV of both machines. So again, let's review the required process. We need to calculate the CV of both machines. And in order to calculate this, we have to calculate effective process time. And also we have to calculate the, no, I'm sorry. This is, we have to calculate the standard deviation or the squared value, that is the variation. We already calculate this value. Now we have to calculate the standard deviation. Wait a moment, please. I have to check some. I have to revise the I was wrong about this. This is not correct. Our assumption is about this, the MF, the coefficient of variability, the variation of MF is 1. So it means that the mean time between failure follows the exponential distribution. And this is very reasonable assumption because and very practically, the mean time between failure is some kinds of the memoryless property. Because any accident of the failure is not related with the past, the historical date result of the failure. So we can assume the failure process as a memoryless one, but we will not limit about this CV of the repair time. We will not use the exponential distribution of the repair time. We will just use the the repair times the CV as a C on the R. So again, we have to calculate the CV or SCV of both machines. And in order to calculate this, we have to calculate this with parameter. And we have already okay. And add this S here. Let's see, not calculate. Let's see how this can be deduced. First, T effective process time is defined as we have already calculated this. And nextly, and this is a little bit complex formula, and we will not deduce. Actually, we cannot deduce this formula in this class. So we will adopt the previous result. And this is written like this. This is the effective standard deviation or effective the variation of this machine. And all parameter is already known. You have already known the natural, the standard deviation and availability from, I'm sorry, it's not like this. It's like this. And also, we know the repair time, and we have assumed the standard deviation of the machine failure, the repair time as sigma R. And MR, repair time, availability, and natural process time. And we will not deduce how this formula comes out, but I'll give you some hint or basic theory. It means that the variation is defined as the squared value expectation minus the expectations squared value. This is the definition of the variation. For the Korean students, is the 분산 is 평 minus 평. 제곱의 평균 마이너스 평균의 제곱. We have studied in high school. So we already know this one from here, from this value. But it's a little bit complex of this calculation. It's written like this. It is the definition of this scared effective process times expectation. And here we can divide this is the, have you remember these terms? These terms is then Poisson distribution. And so internal terms is related with the number of breakdown. And external term is the total or the possible time. So this is the comprehensive integral for the entire period of time, and inside internal terms is all the possible combination, all the possible number of breakdown. So even though these are very complex shape, but basic idea, basic theory is the expectation, and expectation is calculated as the integral or summation of the multiplication between the PDF. It means that the possibility the density functions and all the possible numbers or all the possible the time duration. Anyway, from this definition, somebody can calculate this. And if we calculate this and insert here, and the final shape is deduced like this. I will upload the deduction, the process of this value. If anyone is interested in, or anyone wants to know how to deduce the formula, then please refer that document. So from here, we this is definition. So insert here and insert here. Then finally, the squared coefficient of variation becomes like this. Here. Now we can calculate the effective CV or squared CV of both machines. And if we look into this formula in detail, it can be rearranged like this if we split several terms. Just because these terms multiply here and multiply here, just split like this. Then if we split this formula like this, then we can divide over these three terms. This one, this one, and this one. And let's number each respectively 1, 2, 3. And 1, 2, 3. First terms, C0 square value is just normal variability. Because C0 is defined as the sigma 0 over T0. All the value is belonging to normal value. And second terms is related with the repair time. And this is it related with the random breakdown. Because we have already assumed this variation as CR. So this is random real. The repair time follows as kinds of random distribution. Also even though this term, second terms, is not disappeared, even the variation equal to 0. It means the second terms will be still effective, even in the case of the 0 variation of the repair time. And last third terms is related with the variation of repair time. This is the variability of repair time. But this But third terms will be is not it means that third terms will not effective. It means they will disappear if the variation of repair time is 0. So if we summary this one, if we fix the availability here, this value, not like this. Let's move here. If we fix the availability, it means that if the both machines have same production capacity, then this CE is proportionally increased with the repair time. What this means? This means that long repair time increase the variability. This is the conclusion of this formula. And this result can answer our questions here. Where is it? This question. Which are more disruptive? Short and frequent failure and long and infrequent failure. Most students have answered the second one is better, long and infrequent failure. However, our conclusion is that long repair time is worse compared with the short repair time. So our result of today's lecture is this is the better. And this is the reason why the preventive maintenance is required in order to enhance the productivity of the production systems. Anyway, it's already past the lunch time, so today I will give you the simple homework. Homework is that please calculate this value of both machines. And next lecture, we will discuss more about this. And also we will study the impact of the setup also. The setup or the variability that is the coming from this setup. Okay.